Hello. Today we'll look at equations involving rational expressions. And basically what we'll be looking at in those equations is how to solve for their unknown. Uh, the first step in solving an equation that contains one or more rational expression is to find the lowest common denominator for all denominators in the equation. And then we multiply each term of the equation by the lowest common denominator to clear the equation from all fractions. So there is like an in-between step there, because if the denominator of the rational expression is not factored, I would say first factor the denominator of the rational expression. Okay? So let's start off with a simple scenario where we have a rational equation. So rational equation, we can have x over 2 minus 3 is equal to 2 over 3. This is an example of a rational equation. Notice now, because we have this equal sign here, that makes it an equation. Okay? Another example of a rational equation, we can have 6 divided by a minus 4, and that is equal to 3 over 8. So once again, because of this equal sign here, that makes it a rational equation. Or we can have something a little bit more, I would say, longer. We have x divided by x minus 2 plus 2 over 3, and that is equal to 2 over x minus 2. Okay. Or we can also have something, and once again, this here makes it the equation, the equal sign. We can have 5 over x squared minus 3x plus 2 minus 1 over x minus 2 equals to 1 over 3x minus 3. So this is also a rational equation. Now, if I look back at the first rational equation I wrote, the general pattern is to find the lowest common denominator. So I'm going to work through at least these 4 and probably a few more examples. But my suggestion first is to make sure that the denominators, there's an invisible one there, are factored. Okay. So for example, the first, the second, these here are already, the denominator already factored. But if you look at this example here, okay, the denominator here is not factored, the denominator here is not fully factored. So we'll come to that. So when it's not factored, I think I would strongly recommend for you to factor these denominator first, and then you will get to see what the lowest common denominator is. I had showed a video on adding and subtracting rational expression. In that video, also have how to find lowest common denominator. So let's solve rational equations. So now we want to solve. On the first one I will solve is my first example. X over 2 minus 3 equals 2/3. So x over 2 minus 3 equals 2/3. Now, before I get into solving rational equation, I'm going to make a note of that, and this is very important. It is very important to check your answer or answers to see if they satisfy the equation. And I say this because you will see that some of the answers or answer we get will not work. Okay, so that's very important. All problems must be checked. So let's go back now to our solve. So we want to solve x over 2 minus 3 is equal to 2/3. I'm going to rewrite this, making every term a fraction as x over 2 minus 3 over 1, and that is equal to 2/3. Now, what we'll do is look at the denominator of each term and see if they can be factored. If they cannot be factored, then we move to the lowest common denominator. And what I showed you before, start out with the first fraction, denominator is 2. Then we move to the next, it's a 1. Then we move to the next, and that's 3. So the common denominator is 2 times 1 times 3, which is the same as if I write 2 times 3, right? Now, I'm not going to multiply it out. You can, but I suggest you don't. So common denominator, I'll just write it as 2 times 3. Or I could write the 1 there, it doesn't matter. And now once we have the common denominator, so basically step one is to factor the denominator. Okay. That from here. The denominator if possible. Yeah. And then step 2 is to find LCD. So here's your step 1, here's your step 2, which we did. And then step 3 is to multiply each term by the LCD. So basically what I'm doing, I'm going to multiply the first term, right, by 2 times 3. So I'm multiplying x over 2, and then minus, I'm going to multiply the second term, 2 times 3, by 3 over 1, equals, I'm going to multiply 2 times 3 times 2 over 3. Now what you will notice happens here is that this denominator, the 2, will cancel with that 2, leaving you with 3 times x. And 3 times x we know is 3x. Okay? Now, if there's a 1 in the denominator, right, And I said before we left out the 1 over here, which doesn't really matter because 1 is not going to cancel out. So notice there's nothing to, so if you multiply 2 times 3 times 3, that will give me 2 times 3 is 6, 6 times 3 is 18. And that's equal to, if we look at the side on the right, this 3 will cancel with that 3. So we're left with 2 times 2, which is equal to 4. And now we have an equation that does not have an equal sign. And I know you're much more relaxed now, okay? Because most people, when they see fractions, okay, they tend to get nervous. And now you have a problem that doesn't have any fractions. So you can solve now for x. So step 4 now, step 4 is to solve the equation. If we do this, what we're going to do is add 18 to both sides. And if we add 18 to both sides, we're left with 3x minus 18 plus 18 cancels, and 18 plus 4 is equal to 22. Okay? And then to get x by itself, we'll divide both sides by 3. Okay? 3 divided by 3 is 1, so that leaves me with 1x, and 22 over 3. And then we look to see if 23 over 3 can be reduced. Check, can we reduce? Okay, and since 22 over 3 cannot be reduced, our possible answer is 22 over 3, but don't forget, you have to check. Now, here is what we're gonna check, right? Check, check. I cannot stress the importance of checking. Okay. Now, we see that x is equal to 22 over 3. Now, you don't have to, you should check the entire problem, but if you're in a rush, at least if you put 22 over 3 into that problem, does any denominator become 0? Remember, our problem is x over 3. So in this denominator, there is no x to plug in. Minus 3 equals 2 over 3. So in this case, there is no denominator here to plug in the x. Okay? So we can safely say that x equal 22 over 3 is going to work. Now, if there was a denominator that involved an x, and when you plug in that x, the result is 0, then that answer has to be thrown out, and this problem would have no solution. But x equals 22 over 3 will work. Okay? And you will see more examples of this when we check what will happen. Let's look at the second example that I had wrote earlier, and that was 6 over a minus 4 equals 3/8. Okay? So we now want to solve 6 over a minus 4, and that is equal to 3 over 8. So remember, step 1, we'll factor the denominator. But if you look, this denominator and this denominator here is already in simplified form. So the lowest common denominator lowest common denominator is equal to a minus 4 times 8. So if I multiply the first term by a minus 4 times 8, and I'm going to multiply the 6 over a minus 4 equal to, well, it doesn't matter which side I write it on, a minus 4 times 8. Now notice what will happen. This a minus 4 will cancel with that a minus 4. So leave me with 8 times 6, and that's 6 times 8, or 8 times 6 is 48, equals to, on the right side, the 8 will cancel with the 8, leaving me with 3 times a minus 4. Now, once you multiply by the lowest common denominator and you simplify, you must have a problem without any denominators except 1. And if you have a common denominator, if you still have a denominator, you did something incorrect. So we have 48 is equal to 3 times a is 3a, and 3 times minus 4 is minus 12. If we now solve for a, okay, we're going to add 12 to both sides. And if I do that, 48 plus 12, this becomes 60. And that is equal to 3a. The minus 12 and the plus 12 become 0. So we have 60 is equal to 3a. And to get a by itself, I will now divide both sides by 3. And 60 divided by 3, that becomes 20, is equal to 3 divided by 3 is 1, so that leaves me with 1a. So a is equal to 20. Now, remember, check. If a is equal to 20, and you put a into the denominator, if this a here, the only thing that will make that denominator 0 is if a is 4, right? If a is 4, then we have 4 minus 4. 4 minus 4, that will be 0. But our answer is 20. So a equals 20 is our answer. If a was equal to 4, then this problem would have no solution. Okay? Let's look at the other example I wrote when I started, and that was x over x minus 2 plus 2 over 3 is equal to 2 over x minus 2. So let's look at that. So we want to solve x over x minus 2 plus 2 over 3, and that is equal to 2 over x minus 2. Okay. So factor the denominators. That's our first step. There's nothing to factor here, nothing to factor here, and nothing to factor here. So I can go ahead and say my lowest common denominator is x minus 2, which is this here, times this one here, which is 3, times this one here, which is x minus 2. But if you notice, these are repeated. So I don't need to write it twice. So x minus 2 times 3. That's it. That's my lowest common denominator. We do not have to write this here. Okay. So common denominator is x minus 2 times 3. So I'm going to multiply each term by x minus 2 times 3. So I'm going to multiply the first term, which is x over x minus 2, plus I'm going to take the x minus 2 times 3. I'm going to multiply times 2 over 3 equal, I'm going to multiply the x minus 2 times 3, and I'm going to multiply 2 over x minus 2. And notice what will happen, right? As I said, the denominator will always cancel with something in the common denominator. So you're left with 3 times x, which is 3x, plus, notice once again, the denominator cancels with something in the common denominator, and you're left with this times this. So we have 2 times x minus 2. And that is equal to, notice once again, the denominator cancel with part of the common denominator. So I'm left with 3 times 2, which is 6. Or we can write 3 times 2. Simplifying, we have 3x, 2 times x, positive 2 times x becomes 2x, positive 2 times minus 2 becomes minus 4, and that is equal to 6. Notice we have like terms on the same side of the equal sign. So 2x plus 3x becomes 5x minus 4 is equal to 6. And if we add 4 to both sides, we have 5x minus 4 plus 4 is equal to 0, or cancels out, and this is now 6 plus 4 is 10. And to get x by itself, we will divide both sides by 5. And 5 divided by 5 becomes 1x, and 10 divided by 5 is 2. And don't forget, check, check, check. Now, remember, the original problem, or the problem we looked at, our problem was x over x minus 2, right? That's the original problem, this problem here, okay? Plus 2/3 equal 2 over x minus 2. So plus 2/3 equals 2 over x minus 2. And we want to check x equals 2. Okay. Now notice what happens now. If you replace x with 2, the denominator becomes 0. Okay? Because you will have x over, we replace x with 2. Okay? If we replace x with 2, you will see here that this denominator becomes 0 and this denominator becomes 0. Once one denominator becomes 0, you cannot use that as a solution. So this becomes x over 0 plus 2 over 3 equals 2 over 0. So anytime one of the denominator, this is where the problem is. It doesn't matter if it's 2 of them or 3 of them, or once one of them becomes 0, okay, x equals 2, x equals 2 does not check. So there is no solution, no solution. So although you got an answer, the answer you get does not work. So the problem does not have a solution. Okay. This is the reason why it's very important for you to check your answers, because it may appear or you may find an answer, but when you check it, that answer will not work. And if the answer does not work or produces a 0 in the denominator, then you have no solution to this problem. Very important. Okay. So let's look at the other problem, solve. And we're now looking at the last example of the one, well, at least the last problem I wrote. Here we have 5 over x squared. So now we look at this problem here. Okay. 5 over x squared minus 3x plus 2 minus 1 over x minus 2, and that is equal to 1 over 3x minus 3. So let's solve that problem. So the problem is 5 over x squared minus 3x plus 2 minus 1 over x minus 2, and that is equal to 1 over 3x minus 3. Now, if you look at this problem, we see we can factor there and we can factor here. So by factoring, we have 5 over, if we factor this denominator, we will have x minus 2 times x minus 1 minus 1 over x minus 2 equal to 1 over, by factoring here, we have 3 times x minus 1. Now that my denominators are fully factored or written in factored form, okay, I can find the lowest common denominator. The lowest common denominator will start out here, which is x minus 2, x minus 1. Then we move here, which is x minus 2. Then we move here, which is 3 times x minus 1. Now, notice a few things repeat. So if they repeat, I said we only need to write them once. So here we have x minus 2. Notice that we have an x minus 1 repeated also. So x minus 1, and then we have a 3 there. So we put the 3. Or it doesn't matter if you write it here. So finally, my lowest common denominator, the lowest common denominator is 3 times x minus 2 times x minus 1. This here is just a common denominator, but not the lowest. So we'll multiply now each one of our fractions, okay? We'll multiply each one of our fractions by 3 times x minus 2 times x minus 1. I'm going to multiply that by the first, which is 5 over x minus 2 times x minus 1 minus, and I'll multiply again, 3 times x minus 2 times x minus 1. And I'm going to multiply that by 1 over x minus 2. Okay. I'm running out of space, so equals 1 over 3 times x minus 1, and we have to multiply that side by I'll write it above here, 3 times x minus 2 times x minus 1. Okay. So by rewriting that, now appears to look a little bit better. So let's see what will cancel. So the x minus 2 cancel with the x minus 2, the x minus 1 cancel with the x minus 1. So I'm left with 3 times 5. So here we're left with 3 times 5 minus what will cancel out here. This x minus 2 will cancel with that x minus 2. So that leaves me with 3 times x minus 1 times 1 equals to what will cancel out on the other side. The x minus 1 will cancel with the x minus 1 here. The 3 also cancels out with that 3. Okay, so here we had this times that left. Here we have 1 times x minus 2 left. So 1 times x minus 2. If we now multiply, we have 3 times 5, that's 15. Okay, minus 3 times x, or we can say minus 3 times this 1 first becomes minus 3, and then x minus 1. And then we distribute the minus 3, so minus 3 times x is minus 3x. Minus 3 times minus 1 becomes plus 3, equals to 1 times x is x, and 1 times minus 2 is minus 2. And now we look for any like terms and combine them. So we have 15 here and a plus 3. Those are both like terms. So we have 18 minus 3x is equal to x minus 2. And now I can solve for x. Okay. I always like to move the smaller x first. So when I do this, I always end up with a positive x value. So I don't have to divide. So minus 3x and the plus 3x is 0. And 3x plus 1x becomes 4x minus 2. Notice my x is positive here. Okay. So I'm now gonna add 2 to both sides. And by doing this, we have 18 plus 2 is 20 is equal to 4x. The minus 2 and the plus 2 becomes 0. And then finally, we'll divide both sides by 4. So 20 divided by 4 is 5, and the 4x divided by 4x is just 1x. So now, don't forget, check. So we want to check our original problem. We want to check x equal 5 first of all. Will that produce a 0 in any of the denominator? So remember, we had 5 divided by x squared minus 3x plus 2 minus 1 over x minus 2, and that is equal to 1 over 3x minus 3. Well, if x is 5, we have 5 over 5 squared, our square is in back, minus 3 times 5 plus 2. Okay. Minus 1 over 5 minus 2 equals 1 over 3 times 5 minus 3. And all we do, if we care right now, is any one of the denominator, does it become 0? Okay, that's all we care about. So we have 5 over 25 minus 15 plus 2. 1 over 5 minus 3, 5 minus 2, and 1 over 3 times 5 is 15 minus 3. So you can already see that none of these denominator will become 0, right? You can already see this. So this becomes 5 over 25 minus 15 is 10, okay? 10 plus 2 is 12. So this is okay. 1 over 5 minus 2 is 3. This is okay. And 15 minus 3 is 12. That's okay. We don't have a denominator in the 0. So x equals 5 is a solution, or is this solution. Okay. So once the denominator doesn't become 0, we're safe. Okay. And that's the reason why you have to check your answers. If you do not check your answers, you're in problems. If we look at another example, solve y minus 4 divided by y squared minus 5y, and that is equal to 2 over y squared minus 25. So notice that you can factor here and you can factor there. So by factoring, this here, you have y minus 4 over y times y minus 5. That is equal to, here by factoring, right, y squared minus 5 squared, which is equal to y minus 5 times y plus 5. So we have 2 over y minus 5 times y plus 5. So once they're in factored form, we can find our lowest common denominator. Here we have a y. Here we have a times y minus 5. Then we have a y minus 5 again. We don't need to write it. And here we have a y plus 5. So y plus 5. Yeah, we don't need to write the redundant terms or factors. So we'll multiply y times y minus 5 times y plus 5. And I'm going to multiply that by y minus 4 over y times y minus 5. That is equal to 2 over y minus 5 times y plus 5. And I'm going to multiply that term also by the common denominator, which is y times y minus 5, y plus 5. So notice that the y will cancel with the y, and the y minus 5 will cancel with the y minus 5. So what do we have left? We have this times that, which is y plus 5 times y minus 4 equals to, notice here, the y minus 5 will cancel with the y minus 5. The y plus 5 will cancel with the y plus 5, leaving with 2 times y. So 2 times y. Now we have to multiply this out, or FOIL it out, as you generally would say. If you multiply that out, you will get y times y, which is y squared, y times minus 4, which is minus 4y, 5 times y, which is plus 5y, and 5 times minus 4, which is minus 20. And we have some like terms here to combine. So we have y squared minus y minus 20 is equal to 2y plus y. Minus 4 plus 5y is plus y. Now, because this is quadratic, okay, you have to solve this by letting equal to 0. So what we have to do is minus the 2y on both sides. If I do this, I have y squared plus y minus 2y will be minus y minus 20, and that is equal to 0. Now, by factoring this, if we factor this, because we cannot solve quadratic unless we factor it out, we will have y minus 5 and y plus 4. And that is equal to 0. And now what we do, we take each factor, y minus 5 is equal to 0, okay? Or y plus 4 is equal to 0. And if we solve y minus 5 is equal to 0, we will add 5 to both sides. And if we do this, we have y is equal to the minus 5 and the plus 5 is equal to 0, and 0 plus 5 is 5. Okay? Or on the y plus 4, we will subtract 4 on both sides. And if we do this, we have y, the plus 4 and the minus 4 become 0. And that is 0 minus 4 is minus 4. Don't forget, check, check. So what happens if we plug in 5 and minus 4? Yeah. Well, remember our original equation, right? You could go back to the original, or you could just plug it into the factored version. So our original equation that we had was y minus 4 over y squared minus 5y equals to 2 over y squared minus 25. Remember, we're saying y, okay? So we want to check y equals 5, and we want to check y equals negative 4. So we have two checks here. So let's do this one here first, okay? If we do this, we have y minus 4 over 5. Oops, let's plug that in a different color. 5 squared minus 5 times y, which is 5. We want to see if equal to 2 over 5 squared minus 25. And then we also have to do the other one, but let's finish off this first. So if we do this, we have y minus 4 over 25, because y squared is 25, minus 25, 2 over 25 minus 25. And clearly this is 0, so we have y minus 4 over 0 equal 2 over 0, and this here we cannot. So we cannot use y equals 5, okay? So y equals 5 will not work. Let's check the other answer. So we're going to take now this minus 4, and we also have to see if it will work, because we say either one of them should work. Yeah. So if we do this, we have y minus 4. Okay, let's write the or a little bit. Y minus 4 over 4 squared now. So negative 4 squared minus 5 times negative 4. Okay. Equal to 2 over negative 4 squared minus 25. Okay. Now let's see if we simplify this, do we have a 0 in the denominator? So we have y minus 4 over negative 4 squared becomes positive 16, and negative 5 times negative 4 becomes plus 20, equals to 2 over, we said negative 4 squared is 16 minus 25. So we have y minus 4. Actually, I should have plugged in the minus 4 here also, likewise here, but I don't really care for the numerator, I just care for the denominator, right? So 16 plus 20 is 36, is equal to 2. 16 minus 25 is 9. So this is good, that's good. So the only solution that will work, x equal minus 4 will work. Okay. So the only solution is y equal negative 4. Now you will hear later on of a word we say, okay, we say y equals 5 is an extraneous solution. And what this means is just that it is a solution, but a solution doesn't really satisfy the equation. Okay, that's all it means. So we do have a solution, but it will not work, so we ignore it, we throw it out. So here we have learned how to solve these equations. Now the next step, or which you will see later, is the whole idea of what does the graph of a rational function look like? Okay. What is the graph of a rational function? So later is what does the graph of a rational function looks like? In addition, okay, how do we graph it? Well, if I give you a rational function, right? An example of a rational function would be, for example, y is equal to 6 over x minus 2, right? That's an example of a rational function. And as we said, y, since this is a function of x here, we can also write this as f of x, a function of x, is equal to 6 over x minus 2, right? If this is x, then they should see an x here. So this is written, this what you will see more of rather than y equals. Now, we know first find the x-intercept and also find the y-intercept. Okay. Remember, to find x-intercept, we let y equal 0. And to find y-intercept, let x equal 0. So if we let y equal 0, okay, remember we have y is equal to 6 over x minus 2. If we let y equal 0, okay, we'll have 0 is equal to 6 over x minus 2. And you will see that this here has no solution. Because this is like 0 over 1. The common denominator is x minus 2, lowest common denominator. And if you multiply both sides, you'll get 0 is equal to 6. So here we have no solution. If you multiply both sides by x minus 2, this side will become 0. The x minus 2 will cancel, so you have equal 6. So there is no x-intercept. And yes, there will be functions or any graph. No, not all graph must have an x-intercept. Now, if we let x equal 0, remember we have y equals 6 over x minus 2. If x is 0, we have y is equal to 6 over 0 minus 2. And that leads to y is equal to 6 over negative 2. So y is equal to negative 3. Okay. So our y-intercept is 0 comma minus 3. So automatically, if you look at a graph here, there's a few things you know. Okay. If you look at the graph, and I will do it on the side here, we have seen already y-axis, x-axis, that we do have a y-intercept of minus 3. Okay, we already have a y-intercept of minus 3. We do not have any x-intercept. But what I do want to point out to you is that if you look at the problem, okay, if you look at your function, f of x is equal to 6 over x minus 2. Now, because if you notice, x cannot be equal to 2. Because if you take 2 and you plug it in here, you will get 2 minus 2, which is 0. So because this is x, this is what we call at x equals 2, we have a vertical asymptote. Okay. And the way we draw vertical, remember it's vertical, asymptote is a line, but because it's vertical, it will be a vertical line passing through the point x equals 2. Okay, passing through the point x equals 2. Now, to get the graph, what you're going to have to do right now is just make a table of values. Okay, make a table of values where we have x and f of x or y, and we plug in some values, minus 4, minus 1. What happens if we plug in 0? What happens if we plug in 1? And so on, right? We can plug in 2, we know when we plug in 2, it will be undefined. What happens if we plug in 3, 4, 5, and so on? You can plug in as many numbers. Now, if you take, remember, a function is y equals 6 over x minus 2. So if you let x equals minus 4, we have y is equal to 6 over minus 4 minus 2. Y is equal to 6 over minus 6, which is equal to negative 1. And I take that negative 1 and I put it here. If you do the same by plugging in these values that I have over here, and you continue the process, right, you will see by filling up my table, you will get a minus 2 here, a minus 3 here, a minus 6. We know when we plug in 2, it will be undefined. If you try 3, you'll get 6. If you try 4, you'll get 3. And if you try 5, you'll get 2. And if you plot these points, okay, at minus 4, you get a negative 1. So you have a point here. At negative 1, it was negative 2. You got a point here. At 3, it was positive 6. So that's way above somewhere over here. Okay. At 4, it was 3. 4, it's 3. At 5, it's 2. So if I go to 5, it's 2. And if you do this, you will see that you will have a nice picture that looks, this is our intercept. If we connect the dots, you will have some nice looking curve here. And also you will have a curve, something this way. Okay, passing through those points, obviously. Okay. And you will see later on, we'll talk about asymptotes and what really they mean. So this is just a curved line here. So I want to make sure that I put a curved line. That's how at least for now, to graph these rational functions. But we'll talk about graphing rational functions in a video that I have. Okay. So for now, the whole idea was just to solve for x. Okay, how do you solve for x? Or solve a rational equation? So as always, I say at the end, please practice more problems so you become better at this. Remember, practice is what we need to become better, okay? See you in my next video.